So section 10.7 today, and then we'll also do a little review when we meet in our Zoom session. So this is inscribed and circumscribed polygons. I think we've talked about these words a little bit before, or I might have used them and you went, what the heck is she saying? So we will formalize that today. So inscribed and circumscribed polygons, they're pretty easy to figure out as long as you pay attention to the word. So inscribed, you see inscribed, you see the word in. So a polygon is inscribed in a circle. So notice it's inscribed in a circle. So you have to have a circle. The polygon is inscribed in. So I'm going to use a triangle for my polygon. You could use any old polygon you want. But the polygon is drawn in the circle and the vertices are touching the circle. Then you have circumscribed. So a polygon is like circumference, circumscribed about. So a little bit different word here, about. So the polygon is circumscribed about a circle. So you have your circle, but now the polygon is going to be circumscribed about, so drawn on the outside of the circle. And I'm just doing a quadrilateral here. You could do whatever type of polygon you like. But it does need to be tangent to the circle. Each side has to be tangent to the circle. Okay. Then there's another word called the circumcenter. So if a circle is circumscribed, so let's say a circle is circumscribed about a polygon. So that says that we have the polygon and the circle is drawn around it. So I'm going to do it the opposite direction though. I'm going to draw my circle and then do this. Okay. So in this situation, I know it looks like this first one, but it all has to do with what you're talking about. Okay. So in this instance, the polygon is inscribed. In this instance, the circle is circumscribed. Okay? In this instance, we say the polygon is circumscribed, or you could say that the circle is inscribed. So it just depends on what is your subject noun, right? I know, to get a little grammar on you. But here, your subject noun is polygon, a polygon. This one, your subject noun is the circle. So you need to know what your subject noun is so you know how to draw your picture. And then your direct object is the other guy. Okay, so we have a circle is circumscribed about a polygon. There is a center to this circle, and that is called the circumcenter. Okay, can you see that? That's called the circumcenter. All right, so let's go the other direction, and let's say that the circle is inscribed. A circle, subject noun is circle, is inscribed in a polygon. All right, so we have a polygon, and then the circle is inscribed. I'm going to do the circle first because they're always the hardest to draw. And then draw your polygon, whatever type of polygon you want. I'm going to do a quadrilateral again. The center of this circle is called the incenter. Funny that. If the circle is circumscribed, so the circle is circumscribed, it has a circumcenter. If the circle is inscribed, then it has an incenter. Funny, huh? All right. So let's get to some theorems. Here we go. If a quadrilateral being a four-sided figure, okay, nothing special other than four sides. So if a quadrilateral is inscribed, so the quadrilateral is being inscribed in a circle. Here we go. Its opposite angles are supplementary. All right, so here's a theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay. I'm not going to show the proof of this, but maybe we can at a later time. I am going to tell you the story of the plain old parallelogram. Okay, I did not make this up. Once there was a plain old parallelogram named rectangle. Rex was always trying to fit into a circle, that is. One day when he awoke, he found that he had straightened out and was finally able to inscribe himself. What had the plain old parallelogram turned into? Interesting thought. So since we're talking about a parallelogram, we need to make sure that we say that it is a premise. So if a parallelogram, not quadrilateral this time, parallelogram. So if a parallelogram is inscribed in a circle, all right, so our premise, we need to have a parallelogram and it needs to be inscribed in a circle. Then, conclusion, it must be a rectangle. Okay. Let's think about that real quick. We have a circle. We're going to inscribe a parallelogram, which has to be a rectangle, so here we go. All right, that means we have right angles, don't we? If we have right angles, if this is a right angle, then its intercepted arc is a semicircle, isn't it? From here around here, it's a semicircle, which means this line must be a diameter. And the same thing goes for the other diagonal. That also must be a diameter, okay? All right. You also have some right triangles in here, don't you? There's one here, there's one here, there's one this way, there's one this way. So you might need to use Pythagorean theorem at some point. All right. So those are some things to think about. All right, let's do an example, and then we'll be done. Here we go, our example. You are going to be given quadrilateral ABCD, and it's inscribed in circle O. You're going to prove angle B is congruent to angle ADE. So let's look at a picture. Here's your circle. Circle O, and we have a quadrilateral. Notice it doesn't say parallelogram, friends, okay? That's just what we were talking about. And then, actually I want to change this a little bit. There we go. And this is A, B, C, D, E. Okay, so we've got this guy, we've got the quadrilateral inscribed in the circle. We want to show that angle B is congruent to angle ADE. Well, I don't know anything about this relationship as it stands right now, but angle B and angle ADC have a relationship based on our theorem that if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So let's use that. Since a quadrilateral is inscribed in circle O, opposite angles are supplementary. So angle B is sup to angle ADC. So we have a relationship here. Well, this is the one we want to talk about over on this side, but doesn't ADC and ADE have a relationship? Yes. Angle ADC is sup to angle ADE since they form a straight line. We haven't talked about that in a long time. Since they form a straight line, therefore, angle B is congruent to angle ADE. Now here's the way back. Ready? Put on your September-October brain. By the congruent supplements theorem. Did you remember that? Good job if you did. Okay. So that's section 7. Not too bad. I will see you guys at our Zoom.